What we're going to do right now is graph two box plots on the same scale, okay? And so to do that, we're going to put one set of data in L1 and another set of data in L2. So let's start with the real cheese, and let's do 310, 420, 45, 40, 220, 240, 180, and 90. Now go to L2 and type in your cheese substitute values. So that's going to be 270, 180, 250, 290, 130, 260, 340, 310. Now what we can do is we can do one var stat, right arrow, enter, and we can do that for L1. So your 5-number summary for the real cheese would have a minimum of 40, a Q1 of 67.5, a median of 200, a Q3 of 275, and a maximum of 420. To recall what you just typed, you can press second enter, hit the back arrow, or I'm sorry, the left arrow, and hit second 2, and now do one variable statistics on L2. Scroll down on this one, and you can get your minimum of 130. Your Q1 is 215. Your median is 265. Your Q3 is 300. And your maximum is 340. Now you can calculate your cutoff values for max and mins at this time using Q1 minus 1.5 times Q3 minus Q1 and Q3 plus 1.5 times Q3 minus Q1. So let's see here. For this cheese substitute, if I start with the Q1 of 215, I can minus 1.5 times a Q3 of 300 minus a Q1 of 215. So that cutoff value is 87.5. If I then do Q3, which is 300, plus 1.5 times Q3, which is 300, minus Q1, which is 215, the upper value is 427.5. For the real cheese one, again, 1 minus 1.5 times Q3 minus, and the Q3 plus 1.5, Q3 minus Q1, I would have the following: 67.5 minus 1.5 times 275 minus 67.5, and that's a negative 243.75. If I do the Q3 plus 275 plus 1.5 left parenthesis, Q3 275 minus Q1, that's going to be 586.25. Now that's already taking us quite a bit of time to get all these figures. Once you have all these figures down, you're going to want to choose a scale that both of them can fit on. Now the range for real cheese is 420 minus 67.5. If you divide that by 10, it would tick marks be spaced at least 35 units away from each other. If you look at the range of your cheese substitute, that's going to be 340 minus 215 divided by 10. That suggests a spacing of only 12.5. So let them in between, or something they can both be measured on. If you want to go by 40, you can go by 40s. So let's start with, I guess we could start with 0, 80, 120, 160, 200, 240, 280, 320, 360, 400, and 440. Now 440 exceeds both of our maximum values, and 0 is smaller than both of our minimums, so we know that it'll fit. Now, what my suggestion is, let's use our calculator to do this. Let's do the following. Hit second, y equals. I'm going to repeat that. Hit second, y equals. Your screen should resemble this. If everything is turned off, we need to select the number 1 plot by hitting enter. Notice how the cursor is flashing on the on. Press enter again to now make the on the shaded of the two. Go down arrow once. Down arrow has put you in the type of graph the calculator can graph for you, and you use the right arrow to cycle through all your choices. The first one is a scatter plot. Second one is a line graph. Third one is a histogram, something we could have used when we were graphing histograms. Next one, notice it looks like a box plot with dots after it. This is a box plot that will identify outliers for you. The next one is a box plot that will exclude outliers. We're not going to use that one in this class. And this one, it's another line graph. In Ojive, I don't recall, but I think it's another line graph. So let's go back to this. Make sure your cursor is flashing on this graph when you press enter. Go down. Have it on L1. Keep your frequency as 1. And then choose the mark your outliers. Please do not choose the third choice. That pixel is just too small. Choose either the circle or the plus sign. I'm going to choose the plus sign. Okay. Zoom, which is the button right here in the middle below your screen. If you hit zoom, then you press 9. Okay. Uh-oh. If your calculator shows more than just the box plot, that means you have functions in your y equals button. So press y equals, find what you don't want,